Okay, guys, I think we're going to go ahead and get started. There's a couple more people that are logged in that haven't quite connected to the audio yet or called in, but they're going to be in shortly. So just wanted to go ahead and get started. So today is the second day of our advanced webinar for the coastal modeling system. And today we're scheduled to be talking about some various structures and their use within the coastal modeling system. So you can see on this first slide, we put together 3 CHETN's technical notes, actually 4, on the various structures back in 2013. And since that time, there really has been no integration of these features within the SMS, but we are working on that, and they'll be available in 13.1. Probably not when it immediately comes out, but through one of the updates. But we'll be modifying this a little bit, but I wanted to go ahead and cover some of the structures that we have made use of in a couple of projects here. And so today we're going to be covering Weirs and Rubble Mound jetties, but there are also capability for culverts and tide gates as well within the CMS. And you see on the right-hand side here the 4 CHETNs. If you want to read about these different sites, what you can do is go to the SERP website, and under publications, they're under tech notes. And if you look back in 2013, there are these 4 implementation of structures. So that gives a little bit of background information on each type, some of the theory equations that are used, and examples where we started them up. And I'm going to be, like I said, I'm going to be covering the Weirs and the Rubble Mounds today. So to get started, so the first one I'm going to cover are Weirs. And just like we did yesterday, we're going to go over presentation first, and then we'll go in and do some demo. And I'm probably going to cover both the Weir and Rubble Mound in the presentation first, and then go through and do the demo for each after that. So I'm not going to separate them out. But anyway, the first one is the Weir Structures, and there are a few different parameters that are needed for defining these. I've given a little table here that basically separates these different types out, giving you what the card name is in the parameter file that we'll need to work with and add to define the different parameters. And so the first one is a method for calculating the flux. And so there are 2 approaches. Approach 1 requires pretty much all of the various parameters and information. Approach 2 neglects 2 of these, and so you don't have to worry about setting those 2 cards up when we get to that point. So a little bit about the approaches is given here at the bottom. We have a small equation here. And then approach 2 is basically, it uses normal momentum equations as are already in CMS with a couple of different variations on the values to work with those. So Weir coefficient, so basically you would provide a pair of values for each Weir. The first one would be the coefficient needed for direction from the bay towards the sea or behind the barrier to the other side, and then the opposite direction is second. Crest elevation in meters, and note I say this is positive upward, so those values are required for both approaches. You would define a Weir type, either broad or sharp crested, so those values are 1 or 2. Distribution coefficient, and then the orientation, the direction of the seaside in relation to the weir that we're creating here. And so you see here it's 1, 2, 3, 4 for north, east, south, and west. So we'll be going over this a little bit more in detail as we get into the demo, but I wanted to just present this so you can see what was needed, what can be neglected based on your second, if you choose the second approach. So to get started, I've put some files together just like I did yesterday. So they're under day 2. I have a folder there called Weir, and then a subfolder under that called Start Files. There's enough information there, a fundamental project, that you can load in this rudyweir.sms into SMS 13, and it will load as much information as you would have normally already put together in the course of your hydrodynamic, getting your grid ready. So, our basic webinar covered all of that information, creating the grid, defining the hard bottom and, not the hard bottom, but the Manning's in and other different data sets that would be needed. And we're going to cover a few more things that are specific to working with the structures. So you would load this project in, and after that, you need to figure out where you are going to be defining your weir. So in this case, we have the inlet here, we have a separated breakwater here with a weir on the inside here connecting the exposed breakwater with the shoreline. And so what we need to define are the cells in this grid that correspond to those weirs. And we're going to, for this example, we're going to break this up into 2 different sections. And so what you would do is you would go through and click on a cell and then make note of the ID number that shows up at the bottom. And I know this is really tedious. That's why we're working on a better interface for this in 13.1. So you'll just define a polygon here, and SMS will automatically know what cells are included in that and write all the information out. But for right now, what we need to do is to keep track of this information. And so we would just go through and click out the cells. So the first one here is 16, 864, and then it goes up to 865, 866, 867. And we, like I said, we are going to separate this into 2 different weirs, because the weir here has 2, or can have, one of our alternatives is that it has 2 different crest heights. And so one section of it is higher than the other section. So we select those, and you just can write those on a sheet of paper. You could go ahead and put it into a file, because we're going to be creating a file to help us work with CMS and SMS to get all these parameters and information together. So just open a text file and start putting these cell numbers in. Make sure you remember the direction and where it starts from, because the other values that we give later on will pertain to those individual cells in the same order as they were written in the first place. So just take careful attention to that. And so this is the information that we would be adding for the weirs to a text file. And so we've modified the CMS code to where we can write these extraneous files, cards, together that CMS will read, but they're not necessarily stuck into the main parameter file, the CM cards file. So this is an additional file that CMS will read that has extra cards that it may need to pay attention to. Because right now in SMS 12.0 and later, up until the next version, the advanced tab that we used to collect these extra cards with is gone. And so there's no way for us to just write them into the interface and then have SMS write those files out or cards out for us. So we're going to have to do that by hand, and we have this extra file called advanced.cm cards that we'll place into the same folder with our other files. So the format is relatively simple. We have a begin and end. We have a little block structure there in the card file for the Weir. The next line shows that we're going to have a total of 2 Weirs, and the number of cells in each Weir is 8. And so again, if it just so happened that the second Weir that we were defining had 10, you'd have to make sure that it was in the right order, because it's going to be reading through these cells and assigning them in a proper order as you define here. So in this case, we do have 8 and 8, and so we start listing out the cells. And so 1, 2, 3, 4, 5, 6, 7, 8, and then the next 8 are here. In this first case that we're going to be working on, we're going to be using method 1, which we show down here, and these cards really don't matter the order except for these first 3. So those first 3 need to be at the top, so we make sure that we're working with the right number of cells, and then the rest can come in really any type of order. But the method we're doing is the approach 1, and so we need the distribution coefficient and some of the other information here. So then we specify the distribution coefficient, and we have the values for every cell, and in this case they're all the same, 0.95. The orientation is 3, so if you remember, 3 was from the south. Type is 2, and so in our case 2 is broad-crested Weirs. And then the flow coefficient, and we needed pairs of values for each Weir, and so in our case we're going to have the same coefficient for both, and that's from the sea to the bay and the bay to the sea on both sides. And then the crest elevation, as I mentioned, we're having 2 different crest elevations for the various Weirs. One is set at 0 and one is negative 0.22. And again, the method is 1 and 1. If you wanted to use the other approach, then that number, of course, would be a 2. And so this is just one of the cases we're setting up. It's relatively simple, and to get this into the interface is going to be a relatively simple thing to do as well. So once we are able to have that, then we'll have a small, simple screen. I'll show a mock-up of that at the very end of the presentation today. All right, and so I'm just going to go ahead with this one example, and then what we would do is we would save the project, export the files, launch the simulation. As I said, make sure you write the advanced cards and put the file into the same directory as these exported files that we're going to run or to write out. And then after you're done, then you can bring in the results as always, the solution, and then visualize what's going on. And in this case, I ended up running 6 different cases here. I have 1 case where there was no Weir. I have 5 cases where there were variations on the different parameters, and I've done a difference of one of the alternatives versus the no Weir case. And this is just one particular time. I can't remember if it was an ebb or a flow. Or flood. So, but anyway, this is just some of the differences, the change in velocity for this particular time in this run. So that's pretty much it. Once you do that, like I said, you can visualize and then move on and do what you need to do. So some of the information is written out to the diagnostic files. So if you have any trouble, you should be able to look at those and hopefully figure out what's going on and what's wrong. So I'm going to move from there and move right into, as far as the presentation goes, into the next one, which we're covering is the Rubble Mound structures. And this is done a little bit differently than the other. For these, we need 5 different data sets, and in each data set we are putting certain information for the cells that we're going to select. And so one of the data sets is going to contain just a number 1 instead of a 0 that basically says this is one of the Rubble Mound structure cells, and then it will write out those IDs to the file as needed. We also have a rock diameter, and you notice that's in meters, and so we have a data set specified for that, and this is per cell that are to be included in this Rubble Mound jetty structure. We have a porosity, the depth of the base, and then a method type. And so the method type can be 1, 2, or 3, and that's basically how the Forchheimer A and B coefficients are decided and given values. And I give a little bit from the material, the CHETN and the other stuff. I've given the equations for those different 3 methods, as well as the years that those were published, so that you have some idea of what's going into the A and B coefficients. And so the D is the rock diameter, the N is the porosity, and the V is the water kinematic viscosity. So anyway, that's the difference between those method types, and those are really the only 5 things that you need to define for rubble mounds. And so we're going to go in and once again I have a day 2 folder, I have a rubble mound subfolder, and then the start files just like I did before, and it's got a project already loaded, and in this case it comes in with the depths, a D50, hard bottoms defined, and a bottom friction. It also has the boundary conditions already set and the activity classification for the cells, so it knows land or water. And then what we would need to do is to define the different areas that we're going to be selecting cells for our rubble mound jetty. And so in this case, we're just going to select this one little section, which in reality for Dana Point was an area that was degraded, and they were having flow, and they were starting to get buildup of sediment on the backside. And so we wanted to investigate that and check a few things out. And so what I've done here is just gone into the map module, and just like we did yesterday, we just create a polygon. We just click that out, make sure it closes on itself. And then from that, we can then select cells later on and change their values. But before we do that, we need to create the 5 different data sets for specifying those different parameters. And so that's done through the dataset toolbox. So under data, dataset toolbox, there's a data calculator here. And we just need to do this 5 times and initialize 5 different data sets to the value 0. Yesterday it was -999. For this particular structure, it was done a little bit later, different. The default value is 0. And then just give an ID, a data set name to each one of them. And I just mainly use ID, rock_D for rock diameter, porosity, base_D for base depth, and then the word method. And I just create those. I'll default it to 0 values. And then we can go in and, as we did yesterday, select the cells inside the polygon and then change those values according to what we need. And so just really quick, you would select the polygon for this cell in the map module, or this polygon. Under feature objects, there's an option to select and delete data. And we would select the data inside the polygon for a quad tree and make sure you click the right quad tree if you have more than one, and then click OK. It will select those cells, and then you can go up and on the left-hand side select whichever data set you need, And actually, while these are selected, you could change the values, then change the data set, and the cells stay selected, so you don't have to worry about having to redo the select delete data 5 times. It'll automatically be there. And just for each data set, you would go through and set the values that you wish to use for your Rubble Mound structure that you're going to be running with CMS. And so I've got it down here in on the right here. Just change for the ID data set, just set each value inside the polygon to 1. For the method, choose which approach you're going to be using, which method, and 1, 2, or 3. In our case, we're going to be using 1. And then for the other ones, just go ahead and set the porosity, the rock diameter, and the base depth. And I've got the values that we're using in our example specified here in black. So it's 0.2 porosity, a 1.5 meter diameter, and a 2.0 meter base depth. And this is a view of the area. What we need to do now is just to save the project and then export our files. And that will create all the directories that SMS needs for the simulation. And then we need to write another text file for this advanced cards to specify the Rubble Mound. Later on in SMS 13.1, this will automatically be written out for you. You don't have to worry about these hand editing of files. But for right now, this is what we have to do. So in this particular case for the structure, we need to specify basically 5 lines. So Rubble Mound begin and end block. So within that, we're specifying these different data sets. We need the name of those data sets, the actual files, and then the path within those files. And this is relatively easy to get, and I'll show you that once we get into the demo. One thing you will have to know is that when SMS saves the project, it does not put these data sets in with the actual CMS files, because it really doesn't know that CMS is going to be using it. It just knows that it has that loaded in the data tree and it has them around. So you need to tell CMS either where in the directory path where these files are, or you need to just copy them from that path and place them in the same folder as where your other CMS files are located. And so these are the 5 names that are written out, and I'll show that in a minute. And these are the actual path names. And you notice the name of the path and the name of the file all have the same extension, and that's by design. So it makes it relatively easy to know what to put here. You always prefix it with datasets / and then the name of the data set that you had inside of SMS. Anyway, I'll get to that in a few minutes. Then you would just save, export, and launch the simulation like we did before. And then once it's done, you can bring in those results and then visualize them. And so this is one example of a certain time after the run has started. And one thing to note, in all of these cases, I'm showing this only from a hydrodynamic side. We're not setting up and running a steering case, but normally you would. Normally, to move sediment like it is in reality, you'll be running with both waves and hydrodynamics. But for simplicity and to explain how to do this, I'm only doing showing the flow side of things. So anyway, this is just some preliminary results from the hydro-only run for a certain time, and it's early on. So, but you would bring in those results, visualize them, do whatever kind of validation, calibration that you needed, make whatever changes, and then restart if needed. So, and that is pretty much it. So I mentioned that we are building the interface for 13.1. And so this is kind of how we are envisioning it right now. The user would come in through the map module and define polygons, and when that polygon is selected, they could assign that polygon to be a weir, or actually this is for an arc for the weirs, and then for Rubble Mound jetties it'll be polygons. So depending on what you're using, then you would select the right one. So anyway, you would have all the information that you need, and then CMS can write these things out. You don't have to worry about hand editing your files again. So anyway, hopefully that'll be in there relatively soon after 13.1 has been released. And like I said, that's going to be in a couple of months. We're going to be starting to work on this interface in detail probably the beginning of October, after we get the next fiscal year started. And so hopefully by the time they release, we'll have some of these structures already in there.